introduce Jim's talking points.
Perfect.
Okay, so we're happy to have Jim Sabey. Is it Sabey?
Sabey.
Sabey. Happy to have Jim Sabey with us today. And today he's going to be talking about sustainability and nutrition by growing locally, energy usage and light in a Ceres greenhouse compared with standard greenhouses, and how to have a net zero energy greenhouse. So as Jim says, it's exciting stuff and he's looking forward to sharing it with you.
All right. Take it away, Jim.
Okay, thank you.
Share your screen and everything. So
yeah, first of all, I just wanted to say that our company headquarters is in Boulder, but I live in Windsor. And so before the pandemic, I used to commute like 1 day a week. And so when the pandemic hit, it wasn't a big change for me. I was still, working from home, except that I didn't have that 1 day a week commute, which was really quite nice. So anyway, I have a short 3-minute video that I wanted to play at the beginning, and it was made by people in our company there in Boulder, and there's about 30 people there right now, 30 employees. When I started 4 years ago, there were about 7. So we've grown significantly, and it's interesting what the pandemic has done for a greenhouse company, because people realize that you can't always just go to the grocery store to get your food. And so we've just been inundated with inquiries about people getting their own greenhouses, which is not a bad problem to have. But even before the pandemic, there are lots of reasons for sustainability and for global responsibility for why it makes sense to grow our own food. So I'll share my screen and I'll play this short video, and then I have a PowerPoint presentation and we can start on that. And basically what I'd like to do is, if any of you have questions, except during the video, anytime, just feel free to interrupt, and I'm happy to stop and answer questions. So.
For a long time, I thought sustainability is about energy use, and not until I built my own house did I realize that sustainability includes food and where the food comes from.
There has been a trend in our food system of creating more and more distance between the farmer and the consumer. So whether that be in food miles or actually as a relationship and an understanding of what's happening on the farm and what's happening on the plate, there's a disconnect there. There's an urgency in industrial agriculture to shift out of this model that we've created that is very extractive, both of the people that it employs and the resources that it's using.
We said, okay, let's try something new. Let's look at greenhouses. That's a way to grow food all year long locally with an amazing quality. Clients come to Ceres because we are offering the most sustainable growing solution that is available. We have been able to prove and are continuing to prove that we can grow plants with really minimal inputs and get more yield out of the space than most people can. So Ottawa is an extremely difficult climate to grow in. We are basically in a winter mode for almost 9 months of the year. So that environment that we create, the Ceres greenhouse creates, allows us to take as much free stuff from Mother Nature as we can. It's really important for Colorado to harness the sunshine that it gets. So we're able to do that during the winter time as well, using the passive solar greenhouse designed by Ceres. And this allows us to really control a lot of aspects in our production. As you can see right now, we're growing flowers and herbs, and we're in the middle of January.
Being that schools traditionally are sourcing food pulled in bulk quantities from miles and miles away from where the students are actually consuming the food. And here at Ceres, we care and understand that students who come to school and have healthy, nutritious lunches available to them not only do better in the classroom, but also bring what they've learned and what they're eating at home to their friends and families, where they can make better decisions how they're sourcing their food as well. Fresh food grown nearby tastes better. And with that, it's also likely more full of vital nutrients.
Goal would be that the food is where the consumers are. And I think if you connect the consumers to the producer, because they're in the same neighborhood, they're neighbors. It's community. You're starting to create community. You know what they say? Good food makes good people.
Our main driver is not actually the greenhouse that we built and the facility that helps grow the food. It is actually the food that is grown and the community that is created with that food. This is what drives everything that we do. For a long time, I thought,
There we go. Let me see. It looks like right now, well, let me try and escape. There we go. I was going to say the key for going out of full screen was covered up by all of your photos.
Jim, was that 1 in 5 children, 50%? Do I have those numbers right? I was trying to write it down and then I kind of went to the next slide or the next part of the video, but get half their nutrition at school.
Yeah.
Yeah.
Mhm.
Yeah. I wanted to make sure I recorded that right. Wow. That's hard to imagine.
Yeah. Yeah. It was an interesting video that they made. And I find it pretty inspiring, but really, you know, having worked for this company for 4 years, they're just a super company to work for. You know, they're very laid back, very flexible, but they're also very driven and very philosophy oriented. You know, they're trying to make a difference and not just trying to make a buck. So, all right, let me see if this will go full screen for me. And even this, I should be able to make it go full screen. There we go. No, that's not it either. Let's see, view.
I think it's that little icon to the right of where the disc is at the top. Like there's the save and then there's this play kind of button.
This
Left,
one?
left, left. No, left, left, left. There you go. That one right there. I think that might do it.
There
Yep,
we go.
there you
Thank
go.
you. Yeah.
You bet.
Okay, so this is like I'm a sales engineer right now, and this is basically what I tell people when I talk to them about what is it about your greenhouses, and it's because most greenhouse companies don't pay any attention to energy efficiency. I mean, even though, in spite of the fact that it's a high dollar problem for commercial greenhouses. I don't exactly understand why they don't, but they don't, and it's an interesting situation. So here's some examples of some Ceres greenhouses or Ceres style greenhouses. We do small residential or backyard kits. We do commercial ones, and basically what we want to do is be able to grow year round. And most greenhouses will be maybe a season extender, but most of them don't claim to be able to grow year round inside of them. And if they do, it'll be at a high cost. And you know, because of the way we build our greenhouses, we build them significantly different than everybody else. But they tend to be more expensive because of the materials that we put into them. But what happens is, even though it's a little bit higher upfront cost, the cost to maintain them or to heat them in the winter will very quickly pay for the difference in the cost of the greenhouse. So what we always talk about is we have the lowest cost of ownership in the industry, because even though the greenhouses are more, your overall cost will be lower over time. And I'll give you a couple of examples of that here in a minute. So as a company, we actually don't have a warehouse with greenhouses in them, but we're an engineering company, and we have vetted suppliers that we know will be reliable and will be quality products, and we supply greenhouse kits, and we have those shipped or drop shipped. We have the different components shipped. Like, we build it with a galvanized steel frame that comes from one supplier, insulated metal panels that come from another supplier, triple wall polycarbonate that comes from another supplier, and then various other exhaust fans and inlet louvers and those sort of things. And so that's how we operate right now. This gives you some ideas about standard greenhouses. They're typically lower cost materials, no insulation, high heating, cooling cost, which I mentioned, you know, is a high cost, is second largest expense for North American growers after labor. And they're not designed for harsher climates, or I would also say structurally, they're not extremely very strong.
Yeah, just as a comment, I'd seen a newspaper article here in Lyons, Colorado, just down the road. Somebody closing down their greenhouse because it was costing them something like $50,000 to operate it in the wintertime.
Yeah.
Which it blows my mind.
Yeah.
That's a lot of lettuce. $50,000 is a lot of lettuce.
Yeah, I know, it's shocking. And you know, when I tell people, you know, it's going to be tens of thousands of dollars that it's going to cost you it can be more than $10,000 per month in some months. And so, just like you said, it's a good example. And there are reasons why it loses so much energy. It's because they're large, big volume. They don't have any insulation in it. And so it takes a lot to heat and cool them. This one on the left is probably something that we're going to see this week after that big snowstorm, but this is not uncommon for cheap greenhouses, I should say. So with ours, we build them with insulation around the north, east, and west walls. And we build them with the ones that are for residential will often be done with wood because of how nice wood looks. But really, for commercial greenhouses, wood isn't the best thing to build with, because a greenhouse is a moist environment, and the wood tends to not last as long as a galvanized steel will. And for that matter, the wood ones are also more expensive to build, especially now. You know, I've been noticing that, our steel prices have gone up over the last just couple of months. Like, we hadn't had any price increases for maybe 2 years. And then all of a sudden, the last couple of months, their steel prices kept going up and up and up, and they're up about 30% right now. So our prices are going up too. But compared to lumber, it's tripled in the last 2 years. And so, I don't know that there's any real justification for it, but that's just what's happening. So it kind of trickles up and trickles down, so everything gets more expensive. So this is this is sort of an exploded view of what one of our styles of greenhouse looks like. And it shows the insulated metal panels on the north side. And this one shows it also on the west side. And then the glazing will be on the roof, the south facing roof and the south wall. And if you think about it, most of the time where you need a greenhouse is in the winter. And the sun is typically pretty far south in the winter. And so we don't really, we face our greenhouses south to take advantage of that sun. And there's some other advantages too that I'll get to here in just a minute. And this is the other style, the offset gable. And we do instead of a center gable, which would be more like a typical industrial building, we offset the gable so that we have a longer south-facing roof to allow more sun in, and then just a short north-facing roof, just so that we can provide more space in the greenhouse. The first one is a 23-foot width, and this one is a 30-foot width, which incidentally, if you look at the south-facing roof, it turns out that when it comes down, it's also at 23 feet. So we basically just add another 7 feet onto the north of the other greenhouse. So the polycarbonate glazing that we use is an interesting material. It's got an R2.5, which for a standard greenhouse, even if they use double wall polycarbonate, it's about half of that. And for glass and other kinds of glazing, it's significantly less. And for a hoop house with polyethylene sheeting on it, even if they use 2 layers and blow air between it, it's not even close. And why do I care so much whether it's 1 or 2? They both sound small. But the thing is, in a greenhouse, that's where you lose your heat, is through the lowest insulation value spaces on it, and that would be on the roof and on the glazing. And so when you double that, it just cuts in half immediately the amount of heat that you're going to lose. And then when you also add the insulating value of the rest of the greenhouse, then that's also a big benefit. This is sort of in this little circle cut out there. It shows how the insulated metal panels go together. They interlock, and then there's a caulking that goes in between there, so that it creates not only insulation, but also doesn't allow any air leakage, but also is a complete vapor barrier for inside the greenhouse. Where when it's a moist environment, it really keeps that moisture inside. It doesn't let it get out. And it also doesn't then corrode anything that would be susceptible to moisture. And we've used 2-inch insulated metal panels in the past, which have an R16 value, but it's interesting that the price of a 3-inch insulated metal panel is not much different than a 2-inch. And so we just use 3 inches standard, and it gives us a little bit more insulation. You know, people think of, well, maybe if I insulate that even more, it'd be even better. But the fact is there's a diminishing return, because you're going to lose most of your heat through the glazing, no matter how much you insulate the rest of it. So somewhere between 2 and 3 inches is sort of an ideal place. And like I said, because of the cost, we usually use a 3-inch insulated metal panel. That's a steel coating on the outside and a polyurethane closed cell foam on the inside. I've done a lot of thermal analyses of our greenhouses compared to other greenhouses, and almost always it's a factor of 8 to 10 times difference in the cost of energy to keep it going all year round. Another thing that we have is we have a couple of different methods of storing the energy, because it's part of the benefit is the relationship between glazing and insulation. But the other part is, once the heat gets in the greenhouse, it will escape quickly if it weren't for the insulation, but also because we can store it. So one of the methods we've used is called the GAT system, which stands for ground air heat transfer. And what it does is in the daytime, when the greenhouse will be hot, and even in the wintertime, it'll be very hot at the peak of the greenhouse. And so we'll take that hot air, and instead of exhausting it just outside, we'll pull it down underground and heat up the soil that's underneath the greenhouse through these a series of tubes where air can go through. And then there's a heat transfer that goes from the underground pipes into the soil. And those tubes are made out of a perforated drainage pipe. Now, what that means is that when the hot air comes down, it starts to cool, and it also gives off some of the moisture that's in it. And as it does, that moisture goes out into the soil. Not a lot of moisture, but enough that what it does is it increases not only the heat capacity of the soil, but also the thermal conductivity. So it makes it so that heat can move in and out away from the pipe more easily. It's really a very clever design that, I mean, something like this has been used in lots of other places and with varying success. But this one has been engineered so that we know exactly how long the tube should be and what the diameter of the manifold should be, and all of these things that make it so that it's designed to work. And also because we have hundreds of these installed now, we know that it works. And then at nighttime, we run it the opposite direction so that the warmer air that's in the greenhouse will come back out and start to heat up at night. So during the daytime, we usually don't worry about keeping it warm during the daytime, but it's at nighttime that you're losing your heat. But if you've got all of that heat stored underground, then you can pull it all out at night, and it'll keep every greenhouse from freezing. So it's a way to basically moderate the temperature between daytime and nighttime in the greenhouse. The other thing about this design is that for a standard greenhouse, the light comes in and goes through it, and whatever the plants are, it will hit the plants just fine. But in a Ceres greenhouse, the inside of the insulated surfaces is a bright white, and so what it acts like a mirror. And so it turns out that we get somewhere between 50 and 80% more light and heat by having that reflective area. So there's lots of benefits. And in the winter, what you need is you need heat, you need light, and this not only allows it to come in, but also stores it. This sort of shows a little bit about the difference between summer, the angle of the sun during the summer and the angle of the sun in the winter, and just sort of shows that there's a stronger benefit to having this type of a situation for winter time, which is really what you mostly want your greenhouse for. Here's an example from a greenhouse in Fort Collins, where we did this energy analysis I was telling you about. And what we do is we input into a model the R value of every surface of the greenhouse and then compare it with a standard greenhouse. And you can see that the cost in this particular case, this is not a particularly large greenhouse, but it's 1,980 square feet. So it's not particularly small either. And what we do is we look at the number of heating degree days in any area that we do these. And I would say, at least for my clients, probably half of them are from Canada or even Northern Canada, as far as close to the Arctic Circle. And so the number of heating degree days means the number of days and the number of degrees it takes to keep a structure at 65 degrees Fahrenheit, or you can select a different temperature that you want to see. But I think it's a kind of an industry standard to use 65 degrees for heating degree days. And in Fort Collins, we have 5,883 heating degree days. And in order to keep the greenhouse at that temperature for a standard greenhouse with the R1.5, it's just under 9,000 a year. Whereas in a Ceres greenhouse, it's just over 900 a year. And that's very typical. Almost no matter which ones I do, it's a factor of 8 to 10, a difference in the cost. And when you think about the savings of that over 10 years, you know, just for that one greenhouse, it's over 126,000. And then you think about the cost per square foot of the greenhouse itself and the savings that you get, and it's very significant. This one is a study of light in the same greenhouse, and basically the units that we're using here, kilowatt hours per square meter per day. One way of looking at it is anytime that it's that number is less than 3, you probably should use supplemental lighting. And if you look at a standard greenhouse and the light that it will have, it's got 5 months, January, February, October, November, December, where it's less than 3, so will probably require supplemental lighting. Whereas in a Ceres greenhouse, there's only 1 month that's under 3 and then just barely under 3. So that example where we have about 58% more light in a Ceres style greenhouse. Now this is something that is an interesting material. It's called phase change material. And you know, when something changes phase from a gas to from a liquid to a gas, like with evaporation, that's how an evaporative cooler works. But the same thing is true with changing from a liquid to a solid. And so these little pockets that you see in the back are filled with something called a eutectic salt. And you can think of it as like wax. It's not at all like wax, but you know, we're familiar with how wax is. And when it gets hot, it will melt. And then when it gets cool again, it will solidify. So what happens is during the day, as the greenhouse heats up, it will start to melt this material. And as it's melting, it's storing between, actually, it says 100 BTUs per square foot, but the truth is it's more like between 1 and 200 BTUs per square foot. And what we typically do is we'll line the north wall with this material. And not only is it still reflective, but then it gives us that added thermal storage. And then at nighttime, when it starts to cool down, then it starts to solidify again and just gives the exact same number of BTUs that it's stored. It'll give it right back into the greenhouse. So it's an interesting way of storing thermal energy. And in fact, you know, with the GAT system, it also stores thermal energy, but it stores it somewhere around the temperature of the Earth, which is right about 50 degrees year round. And in the summertime, it's cooler than the ambient air, but in the wintertime, it's warmer than the ambient air. So it has some nice benefits that way, but for certain kinds of growing, you don't want to keep the air at 50 degrees. And you want it a little warmer than that. Now, phase change material, you can order the phase change temperature to be 68 degrees, 72 degrees, 74 degrees, 78 degrees. You know, you sort of figure out, okay, what temperature range is my greenhouse going to go through both summer and winter? And you try to pick a number that says, okay, every day my greenhouse is going to get at least 78 degrees. So everything's going to melt in here inside this phase change material. And then every day it's also going to go lower than 78 degrees. And that's exactly what you want to utilize the storage in this material. You want to pick a temperature where it's going to go both above and below every day of the year.
So do you pick a temperature based on, you know, Colorado or Canada, or do you base it on, you know, is it lettuce that you're growing or tomatoes or
Yeah.
what is it that kind of drives that decision?
Yeah, it's a good question. It's both of those things. It's the temperature that you want to maintain and also the temperature of what would be typical inside the greenhouse for that particular location.
Jim, what are some other applications for this material? Like, is it designed? Is it in any way proprietary to you guys, or is it designed for other purposes, or where does it come from?
Yeah.
Are you guys adapted it to this application, or kind of what? This is interesting, so I'm trying to understand.
Yeah, we did. This is material that is typically used in you know, like office buildings and that sort of thing. And what they'll do is they'll put it in the walls and in the ceiling, and they have them now that look like ceiling tiles. And so it just moderates the temperature. You know, it melts and solidifies every day, so that when the temperature is going up, it absorbs that energy, and when the temperature is going down, it gives it back. And so it's a way to save energy, basically.
Is there the application to use it in like a cooling? Maybe I just conflated.
No, that's a great question. It does both. Like
So
if it's starting to get too hot,
yeah.
if it's starting to get too hot, it'll melt the stuff, and in melting, it absorbs some of that energy.
Heat. Yeah.
Yeah, and if it's starting to get too cold, then it will solidify and give it back. So it works on both for cooling and for heating. And that's why you pick one that has a phase change temperature that's right about in the middle of where you want to keep it.
And you'd be able to find this phase change material with like, I mean, you could basically choose your temperature as you would like an R value off of insulation or something. I mean, you'd be able to match it up somehow.
Yeah.
Yeah.
The
Okay.
chemical composition of it is a little bit different for the different temperatures, just because different things will change phase at different temperatures.
Yeah. Great. Thanks.
Yeah.
This and the GAT system, how much do you find this contributes versus the GAT system as far as, trying to keep that temperature at the ideal range?
Yeah, that's a great question. So if you look at this rendering, we dig the GAT system down about 4 feet underneath the greenhouse. And so it's the volume of a GAT system is about the same as the area of the greenhouse times 4 feet, which is an enormous amount of thermal energy that it will store. The phase change material, on the other hand, is relatively, I mean, the kind we have now doesn't look exactly like this, but it's about a 1/2 inch thick, or maybe even a little thinner than that. And it's filled with this material, but it has the advantage of, it has the chemical, because of the chemical change of phase, it has the ability to store significantly more BTUs per square foot than just having the heat move out from a pipe into the soil and back in.
Wow.
That's more just conduction, whereas this has the chemical reaction as well that multiplies it. So what I found is, I did some studying to answer that exact question that you asked. And what I found is that the phase change material, if we use, usually it's about 2 layers of that, it will store about the same amount of thermal energy that a GAT system can absorb and give back in 1 day.
Wow.
So the GAT system, even though it stores a lot of energy, it can't renew itself and discharge itself every day. You can't renew and discharge all of it. It can do about somewhere between 10 and 20% of it in a single day, which means that it'll actually store energy for somewhere between 5 days and 2 weeks in the GAT system. This one, even though it will store it at a better temperature, it will store about 1 day's worth.
Is there, not to make this all about phase change material, sorry, Jim, but does this material have a life expectancy to it? Like it, because it's changing, going back and forth, does it eventually become less effective or have some sort of?
No, it doesn't. It's like, water going from ice to water.
Right.
Yeah.
Yeah.
To water, it's just the chemical property of the material. And
cool.
I mean, the material that holds it inside, that can be punctured or drilled or, something like that. But they warranty the material for 25 years. And, even to talk about a greenhouse in 25-year quantities, is for most greenhouses is unheard of, but ours will go 30 years or more, because of the way we build them and because of the materials that we use for them.
Yeah, that's fantastic. Thank you.
Yeah. This one is kind of an interesting thing. I ran across the guy that makes these in Texas, and it's called a trihelix solar wind turbine. So it consists of 6 photovoltaic panels and 6 vertical helical wind turbines. And it's about 10 feet by 10 feet and about 7 feet tall. And when he first was developing it, it was about a 3 kilowatt system. And by now I think he's got it up to about a 4 kilowatt system. But this is very interesting because it allows you to collect energy not only during the daytime when the sun is shining, but also at night when the wind is blowing, or anytime the wind is blowing. And it's just, we talk about how we could do a net zero energy greenhouse. Well, this is part of it. I mean, first of all, we use about 1/10 of the energy to heat it during the winter, but we do have certain fans and things that are required to keep the GAT system going, or exhaust fans or those kind of things. Or even inside the greenhouse, if you have an aquaponics or hydroponic system, then there's pumps and that sort of thing that do require some electrical energy. And so systems like this, and it doesn't have to be this system, but any photovoltaic system or any wind system can run it. And it doesn't take very much power actually to keep the fans and pumps going. This is just a rendering showing one of our greenhouses with these on the roof. We actually have never put them on the roof, but in theory, they could go there. Oh yeah, I was going to talk also about the strength of it. When we take an order for a greenhouse, the first thing we do is we send it off to a structural engineering firm, and they will take the wind and snow loads in a specific location, and they'll design it for those wind and snow loads to make sure that it will not ever fall down. And then we put the cross braces either in the walls or the roof to support the material. Those are called the girths or purlins, and we put the size and quantity of those based on the wind and snow load. And in some cases, like we've been working on designing one that's in northern Canada that has a 150-pound snow load, and that's a pretty significant one. And then also down in the Caribbean, ones with 150-mile-an-hour hurricane winds. So these are buildings that are designed to be strong and guaranteed to not ever fall down. In the video at the beginning, they were talking about locally grown food and also about the energy required to transport food. But there's another aspect of growing in a controlled environment, and that is the nutritional value. And we've started looking at what are the things that make a difference in how much actual nutrition is in the food, and not just how many pounds of food that you can produce, but how healthy is it for you, and how much benefit is there in the food itself. And so I think that's all of those things are, part of what we're interested in. So that's what I got for my PowerPoint presentation. And so I'm happy to take any questions. I'll stop sharing the screen.
Jim, I thanks, first of all. I don't know that I necessarily have a question, but I did have a comment. You were talking about how, this pandemic has been, kind of good for this industry. I
hate to say that, but
I know, but it's okay. Look, as an economic guy, there's winners and losers to every event. I get it. Embrace the time that you're on the winning side, because it's not always that way, right?
No, for sure.
But I was talking to so when I was in high school and college, I worked for a landscape nursery greenhouse up in Fort Collins, and I still stay pretty close to some of the people up there. And last year I went in there to get some veggies for my garden and stuff, and it was fairly late in the season where everybody had already kind of planted everything, figured I could get everything on discount and whatnot. And there was nothing to choose from. People had come in and just ravaged anything that was green. They stuck in the ground because I guess they decided they were going to be home with COVID. And so, the company, I got to keep it nameless, but they had one of the best years, if not the best, most profitable year they've ever had in their garden center since inception. And this is not a new institution to Northern Colorado. So they benefited massively from that. I stopped in there just the other day to kind of, touch base with some folks and say hi. And they said that they're already getting people trying to like pre-order tomatoes and things like that. And they're like, we don't, this isn't Amazon. We don't have a pre-order system. Like, what do you mean pre-order? And so I think it's just going to be another season in the green industry where, if you've got something on the shelf that's green, whether it be flowers or veggies or whatever, somebody's going to buy it. So hopefully that translates to your business and is a windfall for you guys as well.
Yeah, it definitely is translating to our business. I mean, I it's all I can do just to keep up. In fact, I shouldn't say that I keep up. I'm not keeping up with all of the inquiries and everything. But and in keeping with what you said about, when you go to get greens from someone who's growing, I visited Ken at his greenhouse the other day, and I'm telling you, it wasn't just the fact that there were some greens available there. In fact, they almost weren't available. They had just harvested before I got there, but they gave me a couple of samples of it, and I'm telling you, that is the best. You know, it's like ones that are grown close and that haven't been shipped from South America or someplace else. It's just so fresh and so good. And so there's just a big difference,
Yeah,
not only in the sustainability of producing it, but also in the taste and in the nutritional value.
right. You know, I was going to comment. I drive around in the country here, and I see so many greenhouses that are just, you know, furloughed, you know, and just not producing. And I've got to think that it's operating expenses. I mean, you know, that's
Yeah.
because, you know, as Jeff said, people are very interested in you know, where their produce is coming from these days, especially with the pandemic. And it just seems to me that you know, there's so many of the other style of greenhouses that are just, you know, laying fallow.
Yeah, dormant.
Yeah, I don't know if you guys have thought about that or talked about that or seen that trend, or what, you know, kind of what your comments are on that.
Yeah, like, I mean, that sounds like my daily conversation with everybody. You know, it's like you can go ahead and buy a cheaper greenhouse. You know, you can knock yourself out and get whatever you want for however much you want, however cheap you want to get it. But if you want something that's actually going to be performing year round, then you don't have really that many options. It's like I said, I don't understand why, but we don't have any competition in this type of a field. Nobody else has. Well, in the past, no one else has done it, and now we were just granted a patent for this style of a greenhouse just this year. So we have both international and U.S. and Canadian patents. So
Is it a design on, like, you've got the longer
Yeah.
south-facing roof? Is that the innovation?
it's in the claims and the patent. There's 3 or 4 features that we talked about, you know, and it's the combination of all these features that was
Put
patented.
together, yeah, sure.
Jim, where do you have these installed, and where does it make sense?
So they're installed all over the place, really, but there's a few places that are more difficult, and places that are, you know, okay, so for our greenhouse, the northern climates and the cold weather is just ideal for what we do. And when you start getting into the hot climates, and especially hot and humid climates, then it becomes very difficult, not only for us, but for anybody. I mean, you put a wet wall in there for, you know, for pulling the air through this moist membrane and trying to cool it. And if the outside air is already 80% humidity or higher, it won't cool it because it's not evaporating. And so there's not a good way to cool them. And in a greenhouse, it's like living inside of a solar collector. And so you have, it takes about 10 times the amount of cooling that a regular house would take to try to cool a greenhouse, which means that you have a, you know, instead of a 5 or 10 ton air conditioning unit, you need a 50 or 100 ton unit, which is a huge commercial air conditioner. And people, you know, it's just crazy expensive to try to do that. In the meantime, you know, for high value crops, we've developed a kind of a cooling system that's it's sort of like a geothermal heat pump, but it has some other features to it that include something that's similar to the GAT system, except that it's water-based or liquid-based. And so it has a heat transfer matrix, I would say, it's not big pipes like the GAT system is with air blowing through it, but smaller pipes. And it transfers the heat into the soil or the coolness into the soil and then brings it back. And that's on our website. We call it the Eco Loop, because it does the equivalent of what these 50 or 100 ton coolers do, but it uses significant less energy to do it.
Jim,
It's almost the same price though. It's just, you know, that's why I say it only makes sense for very high value crops.
Jim, if we're talking about high value crops, maybe you could talk a little bit about the I don't know, maybe the marijuana and the hemp industry. Like where does that cross over? I guess Canada,
Yeah,
Colorado. I'm not sure where else even has
sure.
it. I don't use it, full disclaimer, so I don't really know. But
Yeah.
You want to give some commentary around that?
Sure, yeah. So we have three sort of like divisions in our company. One is the residential and architectural greenhouse. The other is the commercial greenhouse, and the third is the cannabis greenhouse. And the cannabis greenhouse, even though the structure is the same and some of the components are the same, it functions very differently because it's a sealed greenhouse. They don't use ventilation. Everything stays inside, and they're required to have, you know, special kind of heating and cooling. That's where the EcoLoop was developed for that industry.
That's regulatory that it has to stay inside, or that's just best growing practice, or what's driving that?
Often it is regulatory because
okay.
of smell.
Oh, okay.
Yeah.
Okay.
When you're looking at the cannabis industry, are you working with the cannabis suppliers or just the growers themselves? Or do you bridge that between them?
Dispensaries and that sort of thing, we don't work with them, but we work with the growers.
Okay.
And I don't know the difference between, when I think of the growers, I think they're the ones who are supplying it, but maybe you meant more retail.
Yeah. So you answered my question.
Okay.
It was whether you worked with not really the dispensaries, but the ones who are collecting it and packaging it. So you are pretty much that place before you get to that. Okay.
I mean, it's the people that have the greenhouses.
Right.
And so,
Perfect.
you know, I've seen articles in Denver and other places about what a huge amount of energy is being sucked away producing cannabis. And you know, when they're willing to spend a little bit more and use one of our greenhouses, that gets cut significantly down. And so that's one of the ways that we're trying to reduce the carbon footprint of not just that industry, but every industry.
It seems like without a doubt, though, that's going to be a trend that's in your favor, because I mean, I don't know. I feel like we're real close to legalizing it on a federal level.
Yeah.
And then all of a sudden you're going to be playing the margin game if you're the grower. And so it's going to matter. I mean, I think at this point, there's so much margin in the crop that it can be wasteful in its production. But
Yeah.
I got to think that you're on topic and on trend as that becomes more and more legalized, if not at some point at the federal level.
Yeah, that's right. Yeah.
So does that other system with the liquid cooling, does that also help in the wintertime, or is it just for cooling?
No, it's similar to how the GATT system works, you know, because the ground, like I say, it's always cooler than the ambient air in the summer, and it's always warmer than the ambient air in the winter. So you can take advantage of that on both sides of it.
Okay. But more expensive.
Yeah.
And how about
we have a couple of vegetable clients that are looking at that in the Caribbean, but it's because they're catering towards cruise ships and, you know, high value restaurants and resorts and that sort of thing. So they can also justify it.
how are the operating costs versus the GATT system?
They're significantly higher because, you know, even this system has something like a 15-ton air conditioning unit plus dehumidifying. So it uses a significant amount of energy still, but it's about, I think I heard it was 60% less than if you had to do it the other way.
Gotcha. Okay. Well, great. Any other questions for Jim? It was a great talk today. Thank you. Thank you very much for coming.
Thank you. Thanks for inviting me.
I'm going to stop the recording at this point, and then we can